Right, let's work on the second problem of the day. Number 56, merge intervals. Given an array of intervals where intervals I start and end, we've seen something similar before with insert interval. Merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Okay. So after the other insert intervals question, I had a little bit of a gander into sort of the intervals pattern. So when comparing intervals A and B, there are a few possible cases. We can say A completely, we'll use double, or we can say A0 is less than B0 and A1 is less than B1. So this is not A is less than B. We can shorten this. So A less than B completely. We also have A0 less than B0 and A1 is greater than or equal to B1. Actually, no, this should be A1 is less than B0, right? Because both ends of A are less than the initial start of B. Then in this case, we have the start of A is less than the start of B, but the end of A is actually greater than or equals to B. In this case, A covers or overlaps with B. Result should be A0 and either, so max of A1 or B1. So in this case, we could have a situation where A starts less than B, but A ends after B, or B ends after A. So it just depends on which one is larger. But that would cover the entire interval. We also have A0 is larger than B0. And A1 is less than B1. This is A is covered by B. Result should be min of A0, or actually, since in that case it would be B0, and B1. Basically, A is essentially redundant. And we'll say same case if we swap A and B around. We could also consider that, let's say that B0 is less than A1, and B1 is greater than A1. So this is like if B is after A, but B starts a little bit before A ends, but B finishes after A. In this case, B slightly covers end of A. Result should be min of A0, B0, and max of A1, B1. Because, well, technically this would be greater than or equals to in that case. And here we would, yes, because B0 is less than A1, so this should be just straight up A0, because A0 would probably happen before B0, because B0 is less than A1, and we assume that A0 and A1 are not equal to each other. And then I think we have, let's see, 1, 2, 3, 4, 5. I think we have one more case where B0 is greater than A1 and B1 is greater than A1. And in that case, A is greater than, or A is less than B completely. Pretty much in the same way that this first part happens. So the start of B is greater than A, and the end of B, of course, is also greater than A. So how do we actually translate this to this problem? Well, our initial solution could look something like this. We can run through the array until, or run passes through the array until no covering flag is raised. And within each pass, we can say compare the first item with the next item, and if they overlap according to our rules above, merge them, and of course raise the flag if we do merge, because then that means that there's potentially another merge that may occur as a result of that, right? This would be potentially, if we ran through and we did a merge each time, this would be n first, it would be n intervals, then n minus 1 intervals, n minus 2, and so on until 1, which would be n times n minus 1 over 2 passes, which translates to O of n squared, or polynomial time, in terms of a solution. Let's see. Can we assume that all of the intervals are sorted by their start time? So that would be something that I'd ask to the interviewer. Are the intervals sorted by start time? Because then we could do something similar to our insert interval, where we basically merge all of the valid intervals together. If not, so in that case, if yes, we could potentially finish in one pass, so O of n. If not, we need to first sort, then run the algorithm, which would be O of n log n, which has the upper bound, or which is bounded by the sort itself, right? We can't go faster than the sort. So basically that's sort of the crux of sort of how fast our algorithm can run. It doesn't say that the algorithm, or it doesn't say that the intervals are sorted, but we can quickly check to see if the test case allows for that by doing something like, so let's put in some boilerplate code. We can say val intervals list is a mutable list of int array, and return intervals list to array. I think this should compile properly. We just wanted to compile first. Is this as array? Let's see. I need to grab you to array. Should be to array, yeah. Type into array. I think it might need to specify to array. Or is that not? Let's see. To array. Don't want that. As array? Maybe array of? What was the thing that let me turn a collection into an array? Or can I just do... Does the array constructor... Let's see, by array... This array... Does this have a constructor that lets me from? This is a little bit of waste of time, but okay. I guess we could just do like an array of size intervals, or of int array. And we just create a blank int array of size 0. Oh. Intervals list.size. And then we'll do the to do initialize properly. Cool. And then let's mess around with this a little bit. So we'll say 1 to 3, 2 to 6. Let's say this is 4 to 5, and then 2 to 6 like that. If this works and this processes, then we have no expectation that the intervals array is initially sorted by the start. So we have to, if we want to do the sort of cleaner method, then we need to sort it. So we need to do an intervals.sort. And this probably takes a comparator. Or comparable. Looks like sort is deprecated. We want sort by. And this takes a selector which takes sort by a selector which is a lambda which takes in the t and returns r. Interesting. So we're gonna need I think a class, we can say interval comparator. Or maybe, let's see if the sorted works first. Oh, we probably need to comment that out. Sorted int array. Infer type is not a subtype of comparable array. Okay. This should return an int. So we need a comparable. And then we can say override let's see. Alright. This is an implementation of comparable of int array, right? Fun compare to b int array. And this has no inputs. This compare to should return an integer. And we can say, so 0 if it's equal. When, let's see. Ooh, how do we do this? Int array comparison. Because this won't necessarily, for type is if this at 0 is equal to b at 0, this returns 1. When this at 0, negative if it's less. And this at 1 is less than this at 1. Positive 1. Or if this at 0 is... Actually, we could just throw in an else here to be exhaustive. Right. And let's see if this actually compiles. Let's see. We need to initialize this interval comparator there. There is no get method. This compare to I'm thinking if I need to make, rather than making it a comparator, I just create an extension function for it. Let me think about this some more, because this is more of an implementation detail than anything. Okay, so it seems like there was an easier way that we could just specify the item that we wanted to sort by. So this is what we're using. So it is defined as the items within this interval, which is an integer array. So it at 0, so the first item in here. And then I'm just running through a pretty simple print function just so I can see what's going on. And it seems like it's printing fine, and it seems like it's sorting fine. So we can move on to our next step. So now that this is done, we can do intervals for each interval. Indexed. If index is less than intervals dot size minus 1. So we want to go to the second last because we no, we actually don't care about this. But this index will probably change. So we probably don't want to use this. We want to use a let's see, a for loop may not necessarily work because that's in there. We could do a could use a while loop. Let's use a for loop for now. I'm not sure how this will exactly break down now that I think about it. We can use an outside index, start at 0, while index is less than intervals dot size index plus plus. So we can control it like this, have a little bit more control. So now, while we are inside our intervals, so we're iterating through. Actually, we could use that. This will probably speed it up a little bit, marginal amount if we need to. Anyways, let's see. What we want to do is to compare the first one with the next one, and if it's less, then we continue, right? So we probably want to go to the second to last now that I think about it, yeah. If intervals at 0, actually we could do a when statement, right? At index at 0 less than intervals index plus 1 0 and intervals index 1 is less than intervals index plus 1 0. Then we can just do intervals list add intervals index. So if the first one is less than the second one's starting point, and the ending is less than the start of that one as well, then we can just add our intervals and move on. However, if that is not the case, let's see. If intervals index at 0 is less than intervals index plus 1 and intervals index at 1 is greater than or equal to intervals index plus 1 So this is going to be a little bit of extra typing. So if our intervals there is less than our if our intervals there is less than our intervals at the start, do we want to make this an OR statement? Right, so if it starts at less than or the same spot, then our val left is going to be equal to our min between intervals index at 0 and intervals index plus 1 at 0. Well, actually, if it's less than or equal to, then at most it can be that. So we can just leave our intervals index 0. We can leave it like that. That's fine. Then for I in index plus 1 to our intervals size minus 1. This is sort of the scanning through the rest of it to see where we end up. If intervals at index, our initial index, at 1 is less than intervals how do we want to do this? Well, let's see. We could do it like as a while loop. And we have this right at 1. And while right, or we can say found location, not found location, or I is less than interval size minus 1, I plus plus, we're going to need a var I, which is equal to index plus 1 at first. And we can say that basically we just want to run through the rest and find out where it stops. So what we really want to do is actually pretty much run through this algorithm again. In that case, I'm thinking of whether or not we want to actually move this into a recursive solution rather than an iterative solution, because we'd be essentially running through this same thing. Maybe there's a more concise way of putting this. Let's think. Index intervals at I0, else if intervals index at 1 if this is then found location is true, and then the right edge will be equal to intervals. Actually, we don't need to change anything in that case. If it's less than the next value. However, if this is greater than or equal to intervals I at 0, then we can say, we could do right, and our right side, our right edge. If it's greater than or equal to, then our right side will be equal to the max between our current right side and our intervals I1. And we don't know necessarily if we found the correct location in that case. Basically, if it's less, then we know that that's the hard edge. If it's not less, then we reset our right side to encompass whatever we have, and then we continue from there. And then, of course, continue until we actually hit the end. And in this case, we can go all the way until that point, because we're not checking the next in this case. Are we? No, because in this, if it is the next, then it just does that. Okay. So at this point, we would basically terminate. Then we can say that we do intervals list add a new interval, so int array of size 2. Can we do an int array that int array of left, right. And let's see. If the intervals at index at 0 is purely less than the intervals at index plus 1 at 0, and the intervals at index 1 is less than the intervals index plus 1 at 1. So basically this is the, I guess, the encompassing case. Let's move this up actually. So this is the covering case. And let's add a bracket around that. We can say no overlap case for this one. In the covering case, we want to add an int array of, actually if this is greater than, then actually do we want to do anything? We want to do intervals index plus 1, and then probably do index plus plus. So skip the next interval that we should merge. in. Actually, do we want to do that? Because there's a chance that this interval compared to the next one will also need to get processed. So actually we don't want to do that. Maybe we just don't do anything. Because the next interval will cover it. No matter what. But in that case, this cannot be true, right? In our sorted order? I mean, it could be true if we did merge something and then... Could it? I'm not even sure this is possible because this is saying that our initial is less than the next, the starting point. But of course, that cannot happen within the context of our intervals, right? Or it should not happen because then it would break. It would mean that the sort is broken. In this case, let's see. Honestly, we could just do this a min of interval index or intervals index plus 1, 0. And that covers two cases, right? So this covers both when we have overlap on the left that bleeds into the right. And then we also have overlap in which we have one that bleeds sort of further onto the right. At least I think so. But again, this is a little bit iffy because we're basically saying that there's a chance that this index plus 1 could be less than this, which I'm not sure if that can even be true. Right. And is it possible for... Let's see. I don't think it's possible for A to be completely larger than B. I think there are actually a lot of cases which cannot happen basically here, compared to insert interval, where, let's see, we create an int array of size intervals list at index. And we create a second opener where we return our intervals list at index at, I guess, inner index. Not very creative with these names, but... And that should copy the array. Or that should move the array from a list into a proper array. Let's see. So we have this case where we don't have an overlap with the next value, so we just add it. Will we have a case like that? 1 to 3, 2 to 6, right? So 1 to 3, we set left to 1. 3, and then we start with 3 as... Well, 3 is greater than 2. Okay. And then we start at index plus 1, which is this one. It's not less than 2, but if it's greater than or equal to that, well, it must be because of the first condition. Therefore, we can just do this. The right is equal to the max of 3 and 6, in which we replace it with 6. So now the interval is 1 to 6, and then 6 is less than 8, so we don't do anything there, and then we add that int array in. And then we move on to the next value. Or, is there a chance that we could merge 2 together? I honestly don't think so. Let's see, looks like min isn't quite a Kotlin thing. Min of, max of. And inferred type is intervals list index size. Oops. And we get an out of bounds exception there. Let's also print out this print int or line left right. We could do the same here. A little bit more type heavy, but okay. It looks like we ran into an out of bounds exception on line 45. Well, interval I has to be less than intervals oh, it might have been different because we added a couple lines. Well, we added one line, so it should have been line U. Let's see. Alright, less than intervals at I. How is that an out of bounds exception at side or at 2? Or rather, how are we going there? Print line I, print line intervals size. Oh, I think this should be an and, not an or. Okay, cool. Left 2, right 6. Okay, let's run them against the examples and let's see where we go. Okay, where are we going wrong here? Okay, so we outputted 8 through 10. We still added 2 and 6. Interesting. Oh, okay. So then we want to skip those in that case. So for each one that we actually go through, we probably want to not only increment I, but also increment index. Um, one, right, 6. Let's focus on this one first. Left 1, right 6 is correct. But then the index went wrong. The index started here, and we ended here. The index increments by 1 each time regardless. The index increments by 1 each time regardless, but it probably incremented to 1, right? Yeah, okay. So in this case, will a merge always happen if the intervals 1 is greater than or equal to... Yes, a merge will always happen, so index plus plus here. Then, The problem now is that we don't actually grab the last value within our, we don't grab our last value within here. Though I'm also curious as to if we cover the case where we do, let's see, let's say 7, or let's do 7, right? And then we do 6 through 7. I have a feeling that this will also break. We'll probably add the 6, 7 block in there mistakenly. Yep. Okay, so we still need to add this index plus plus in here, I think. If we ever go through, I guess, additional blocks. No, that actually broke things. We probably want to increment index here because that implies that we haven't found our proper location yet. But why is our min of there? Oh, because we did that instead. We incremented our index before we did all that. So let's increment before we do that, or after we do that. So 1 and 7. Well, actually, I don't think we need that anymore because we're doing it like that. Left 1, right 7. 8 to 10. That's correct now. But now we also need to consider the right side. Or we could do this, and then we can say if we're at the index we could actually just do this. Index is equal to intervals, or if the index is equal to the intervals dot size, can't type today, or we have no overlap, then we add it. So this will cover it. So now we won't go through, because this is a switch case, right? So that blocks everything else off. I think we're at the point where we could actually try to go for our first submit. Things seem to be working fine for now. So let's comment out these print lines. Let's toss in a submit, and let's see where we end up. Okay, not bad. Yeah, so that's pretty alright runtime, pretty alright memory usage. Again, I feel like you could probably do this in a recursive manner, and it probably does work pretty well in that case. But I decided to do it in an iterative manner. It is a little bit more messy though, especially with all the index manipulation. It just doesn't look quite as nice. But hey, it works, right? So, yeah. In any case, I hope you learned something, and I will see you for the next problem.